Welcome to the deep dive. Ever play a game and just stare at the visuals, wondering how they do that?
Oh, absolutely. The level of detail now is just incredible.
Well, today we're diving into a key piece of that puzzle, high-level shader language, or HLSL.
Right.
Our mission really is to break down what HLSL is and show you why it's so crucial for modern games, even if you're not, super technical.
Exactly. The basic idea, HLSL is a programming language. It speaks directly to your graphics card, the GPU.
Telling you how to draw all that amazing stuff we see on screen.
Pretty much. It powers those immersive worlds.
Okay, so what is HLSL? Fundamentally, you said a programming language.
Yeah, think of it like C, if you know that language. It's got a similar style. Microsoft developed it specifically for writing these things called shaders within Direct3D.
Direct3D. That's Microsoft's toolkit for graphics on Windows, right?
That's the one. And the key thing is high level. Before HLSL, you were often wrestling with really complex assembly language for the GPU.
Which sounds difficult.
Oh, it was. HLSL made GPU programming much more accessible, more efficient, too.
So its job is basically real-time graphics, all those like special effects, lighting, shadows, that kind of thing.
Precisely. Shaders are like tiny programs running constantly on the GPU, figuring out the color and look of every single pixel based on lighting, textures, camera angle, you name it.
Wow.
Yeah, it dictates how light bounces off a surface, how textures wrap around objects, all in real time. It first appeared with Direct3D 9, offering a much friendlier way to code than assembly.
And it became even more important later.
Definitely. With Direct3D 10, the whole graphics pipeline became more programmable, more flexible, and HLSL was, it wasn't just an option anymore. It was pretty much necessary to really use the power of the new hardware.
Okay, so it's tied tightly to Direct3D. Where else do we see it? Obviously, Windows games, I guess.
Yes, tons of Windows games use Direct3D, so HLSL's under the hood there. But it's also huge in game engines.
Ah, like Unity. Or Unreal Engine.
Both, actually. Unity uses a variant that's like CG HLSL, but it lets developers write custom HLSL shaders directly using something called Shader Lab.
So developers can get really specific with the visuals in Unity.
Exactly. And Unreal Engine. It relies heavily on HLSL, especially in their material editor. If you want truly custom advanced visual effects in Unreal, you're likely working with HLSL at some level.
It's fascinating how central it is. But Direct3D is Windows, right? What about games on, say, consoles or Mac? Do they just not use it?
That's a good point. While HLSL is designed for Direct3D, engines like Unity are smart. They often have tools to translate or cross-compile HLSL code into other shading languages, like GLSL, which is used by OpenGL.
OpenGL being the sort of cross-platform equivalent.
Sort of, yeah. It's used on many other platforms. The translation isn't always perfect. You might lose some specific features or need tweaks, but it helps developers target more platforms.
Okay, that makes sense. So let's talk visuals. Can you give us some examples of the kind of magic HLSL enables?
Sure. Think about really convincing water in a game, maybe in Unity. That realistic shimmer, the way light reflects, the motion of the waves.
Yeah.
HLSL is often used there to calculate exactly how that surface should look, balancing realism with performance so your game still runs smoothly.
Right, performance is key. What about different art styles, like cell shading?
Good example. That cartoonish look, often seen in games made with Unreal Engine with the bold outlines and flat-looking lighting.
Very distinct.
HLSL shaders are perfect for that. They let developers control the lighting and rendering precisely to achieve that specific non-photorealistic style.
And even something as basic as shadows.
Absolutely. Real-time dynamic shadows in Direct3D games. That's HLSL, working hard, calculating where shadows should fall, how sharp or soft they should be, how they move with the light source. It's all shader programming.
It really sounds like it gives developers immense power over the final look. So why should someone listening, maybe just a gamer, care about HLSL?
Well, even if you never write a line of code, understanding that this exists gives you, I think, a deeper appreciation for the visuals in games. You start to see the technical craft behind the art.
Like knowing how the sausage is made, but for graphics.
Sort of. And if you are interested in game development, especially using Direct3D or Unreal, knowing HLSL is, frankly, super valuable. It lets you optimize performance and create unique looks that make your game stand out. It's an industry standard for a reason.
So wrapping up, the main takeaway here is that HLSL is this really powerful specialized language that's driving a huge amount of the visual complexity and, the artistry we see in modern video games.
Precisely. It's the toolbox developers use to push beyond the basics and create truly memorable, visually stunning experiences.
It really does make you think differently. Consider your favorite games, maybe ones with really unique art styles. How might HLSL or languages like it be working behind the scenes to create that specific feel? And looking forward, what kind of totally new visual ideas might become possible as this shader tech keeps evolving? Something to ponder. Thanks for joining us for this deep dive.